let's just get started. Because we have a pretty tight agenda today. So I'm just gonna take a few moments here to sort of like set the stage for the workshop. I'm gonna show some numbers. The first one, this is a chart that probably many of you are already pretty familiar, but we've seen a dramatic decline over the years on the launch cost for sending payloads to space. When the cost drops, we see how it materializes by sending more payloads. And we are seeing a new revolution particularly on the LEO, low Earth orbit satellite market that is fueling this new space revolution. It's also expected, this is data from McKinsey, that the space sector will grow up to 1.8 trillion by 2035. And this slide on the robotic side is what it shows the evolution of the cost of the price of humanoids. We see, NASA actually pioneered the use of humanoids, starting with Robonaut in 2001, which used to cost 1.5 million. I think bringing in inflation is probably around $2.5 million. We can see how the trajectory has gone down dramatically, exponentially, until like Unitree with the 40,000, and now more recently, I had to update this slide a couple of days ago, but Unitree just released the new humanoid, more capable than Robonaut back then, for $6,000. Just crazy. At the same time, we're also seeing a dramatic reduction in the cost of digital intelligence, right? This is a chart with the cost per token. I think it's from most GPT-4 or any of the other new frontier models. How it's just dramatically, this is just in 4 years, dramatically reduced 99%. And then physical intelligence, right? We're seeing how AI is also going into the physical realm, thanks to advancements in foundation models, large language models, visual language action models, diffusion, simulation, synthetically generation. We'll hear about that in the coming sessions. But that has given robots end-to-end capabilities now. I was talking with a professor recently who said that what used to be a thesis for for a PhD student, now it could be a project for like a summer internship in 1 or 2 months. Obviously, still there's some challenges and gaps that need to be filled in. It's very easy now to get to the 90%, but the 10% is still challenging. So where are we in the space robots? Well, so far, I believe, and this is actually took the data from our speaker Bryce, I believe it's still less than 30 space robots currently at the moment, right? I think there's still a lot of opportunities to expand, especially as we see the growth in terrestrial robotics and capabilities to bring it to space. Apologies for the siren. We're in a school right now, and apparently this is like the recess, and we haven't figured out how to disable it. So every 30 minutes or so we'll hear that. Now on the NASA side and on the space sector, right? We see that space robotics is a mission enabler, right? We read the Moon to Mars, especially those of you who applied for SBIRs, the STTRs, or the work in the civil sector. Moon to Mars, the civil STMD space shortfall ranking, they all outline how important general purpose robotics will be, right? To sort of like materialize that vision of going to Mars and then developing the technologies through the moon. But there's some of the big areas where space robotics can be critical: logistics, maintenance, and fitting, service and assembly, also for the science side, sample collection, handling, and space inspection, and obviously manufacturing. This is the chart showing all the missions to date and future missions from NASA. This is just the pretty much solar systems outside on the deep space. But this is just all we visited so far. And an analogy is like, this is just a glass of water in a vast ocean of water, right? We know very little. We've gone to very few places so far, right? And there's just so much to explore, right? And I'm hoping that there's still many challenges. but also many opportunities. And I'm hoping with this, through the workshop, we can address some of those and discuss. I think we have a pretty interesting room of speakers and attendees here in the field. And yeah, with that, I just want to introduce the first session for today. We have 3 theme topics. The first one is focused on off-world resources, focused mostly on the moon. Session chaired by Maggie, my co-organizer Maggie Wang. The next one will go into Mars, and we'll explore, what are some of the challenges and opportunities for robotics and autonomy there. And the next one, led by my colleague from JPL, Hiro Ono, will be touching more on the future deep space missions. How does new evolving architectures and robotics and autonomy, how would that look like for, as we think about exploring in one-shot mission, other planets, other celestial bodies. For tomorrow, we'll have a session led by Lutz Richer here as well, and the software team on simulation and digital twins. Then we'll have a special session on Earth and beyond, so space and terrestrial robotics. What is the current state? And then we'll finalize with spotlight talks from our program. And well, I want to thank, obviously, my organizing committee for the tremendous work that we've done over the last few months in organizing this, and obviously our scientific committee as well for all the advice and guidance that they provided, and obviously also some of the sponsors that they have make this workshop possible, Software, NVIDIA, and Alpha Data. So let's go. Let's begin.